robot. In this project we are using an operational amplifier and IC instead of using Arduino. As you know that Arduino is a full-fledged microcontroller used to control the RC cards, LFRs and other automation. So we will implement it on the we will implement a LineFollowingRobot by using an operational amplifier and an IC. The components used for making an LineFollowingRobot are motors, wheels, a caster wheel, IR sensors, along with wires, batteries, resistors, diodes, transistors, and LM393 IC, wires, and transistors. This is our block diagram of LineFollowingRobot. In the center there is an IC connected with the infrared sensors having the output pin, VCC pin and ground pin, and the motors are connected to the IC, which will then move by the signals of the IC. A 9-volt battery is also connected with the IC. Next we have the schematic of the LFR. As you can see, here are the infrared sensors along with capacitors, and in the center we have the IC of LM393. The ammeters and voltmeters are connected for the readings. There is a 2N2907 transistor. This transistor is widely used in electronic circuits such that it can be used as a switch control devices like LEDs, relays and other lower power loads. It is used as amplification. It can often used in low power amplification circuits such as audio preamplifiers, and in sensor circuits it can use to sensor circuits to amplify weak signals from sensors. In this LFR we are using this phenomena of the transistor of sensor circuits. Next we have motors connected to it, LEDs for the indication of the working of a LineFollowingRobot. Next here are the calculations of the LFR along the this is the current along the transistors, that is 0.11 amperes, and the voltage across the transistor is 10.7 volts. If we see the voltage across the motors, it is 1.25 volts, and similarly on the other motor. Now the current on the LM393 of the output terminal is 0. On the other hand, the voltage across it is minus 0.02 volts. In the next slide, there is a PCB layout which will implement on the copper sheet, which is then etched by using a ferric chloride. So the print of the copper wires is printed on the sheet, and the components are then soldered with the helper soldering iron. This is the breadboard circuit of the LineFollowingRobot. Here is LM293. By the way, we are using LM393. You can use any one of that. Here are motors and a 9-volt battery. This is the data sheet of LM393. Basically, the LM393 is popular integrated circuit used primarily as a voltage comparator. Dual comparator. The LM393 contains two independent voltage comparators in a single package, making it versatile from various applications. It can operate from a single supply voltage ranging from 2 volt to 36 volt, or split supply from positive negative 1 volt to positive negative 10 volt. It is also used as low power consumption, high accuracy and ease of use, and it is also cost effective. So it is used in educational projects and commercial devices. That reason we are using it instead of the Arduino. Here are the other some information of the LM393 IC. So now we will understand the concept used in the LFR. LM393, this is a voltage comparator IC that helps in comparing the voltage levels from the IR sensors. IR sensors, these detect the presence of a line, usually a black tape, by measuring the reflected infrared light. Circuit configuration. Connect the IR sensor to the LM393. The output from the IR sensor will be fed into the LM393 to determine whether the sensor is over the line or not. This will help the robot to move on the single line, following it throughout the path. The LM393 will output a high or low voltage based on the comparison of the voltage from the sensor's voltage. When the IR sensor detects the line, it generates a voltage that is compared to a reference voltage set in the LM393. If the sensor is over the line, the output will change. The formula used in the LM393 can be expressed as V out is equal to V sensor minus V reference. If V out is greater than 0, the robot should turn one way. If V out is less than 0, it should turn in the other way. Based on the output from the LM393, I control the motors of the robot. For example, if the left sensor detects the line, turns right by stopping the right motor and running the left motor. If the right sensor detects the line, turn left by stopping the right motor and running the left motor. By this way, the LFR is moved on the single line. Next, we have the motor speed. Using the H206 speed sensor to measure the speed of the wheels. The speed can be calculated using RPM is equal to 1000 over time taken into the 60. The distance traveled can be calculated using distance is equal to 2 pi r into number of rotations, where r is the radius of the wheel. Thank you. That was pretty much it for today. We'll